who knows how any of this would have worked out for any of us if we'd been somewhere else. But what I remember vividly is around the time that I was working for ATI and then starting here, there were about 50 companies who, were in the business, whether they had completely differentiated technologies of their own or they were just adding something on somebody else's chips. And, over time, well, they're all gone. I mean, there's a handful of players left. What do you think has given PowerVR its longevity? I mean, I think I know what my answer is, but...
We had a unique technology, so that was of interest to everybody. It was that little bit, for many, many years, it was that little bit above and beyond everyone else. So, well, that's what we believed anyway. So it kept us enthusiastic.
Yeah, it's the efficiency focus, but I think it's also spotting the opportunities, right? Going from PC to Dreamcast, back into PC market, and then, spotting the massive opportunity in mobile. And in a certain sense now, all the re-emergence of data center and in between automotive, so being able to spot all these new markets and linking that now to the IP model. So the fact that not everybody wants to buy a finished chip, but wants to customize it, tune it, put it in their own optimized system. That is today the real benefit, and that's the growth that we see in the data center now, really. Yeah, that off-the-shelf solution isn't quite right. I want to put my own stuff next to it in a very efficient way is a great opportunity for us.
I think, we were really lucky to get out from under the cosh of PC and to some extent games consoles where, I guess when we were in games consoles, there were 5 players, something like that. Panasonic was still around, for example. And, now that's a market that really has crashed down to 3 notable players. And you win or you lose big. And, the same to some extent was true of the PC. And something that we felt, quite keenly with the Cairo generation products. We will talk a lot more about our successes, of course, but there have been a few moments where, in some ways, we very nearly didn't make it. Where we've lost customers or different opportunities. What about the successes that you're most proud of?
I just remember going to visit Sega when we were going to present to them what was going into Series 2. It was, Arc 1 and then eventually CLX, and saying it does this. I can't remember exactly what it was, whether it was translucency sorting or whether it was you can do this sort of like volumetric fog with this sort of volumetric fog and combine the two together, or the shadows or whatever. And they just go, look at me as if you're talking impossible. You're saying that it'll turn water into wine, and no. And then it suddenly dawns on them that we weren't joking. It could do this, and just the excitement in their face. It felt wonderful. Oh, just getting when we were porting Tomb Raider over, and we got the first one running. It was just wow. It just looks so much better than the software version. Excitement.
But it's not all about the end product either. I mean, I think everybody was pleased that we got into a Dreamcast because we could finally talk to our parents and family and partners about what actually we did, and they recognised it, and they could adjust and stop going blank. But we've done a lot of technology that hasn't been visible. I mean, we brought emulation technology into the business so that we could actually test and verify such complex designs. We led on doing that. We worked with Synopsys and Cadence, and they were getting us to do publicity with them because we were pushing their technology a lot further. We talk about some of the things that have gone wrong on the way, but actually it was because nothing worked properly. All the tools were being generated to make all this work. The working with NEC years ago, you were having to debug their compilers and debug all of their tools on the way to help them develop. And we think about silicon chip design as being really easy now because it is all very, very slick. I mean, it's very expensive and it's very complex, but it's very slick. Back then, we didn't have that, so we were having to bring emulation technology in, which was market leading to test everything. and then develop all the systems around it and put all of the hardware together to make that work. People used to come over to my desk and say, "Can I have a look at the emulator?" And you'd go in, and there would be in this dark room, and there'd be a box that looked like this. It was the only way you could describe it was an Art Deco dishwasher, very large Art Deco dishwasher. And they were just excited to see something because it was so cool that it could do this, whereas before it would take weeks to run simulations. So introducing all that technology, that made the difference for us to be able to be able to develop what we did. The first time we ran tests on that, we found a bug that couldn't have been found in simulation because it was done at a system level, and it would have cost our customer a complete tape out to fix it. It's those sorts of things that make us proud to have done what we do. Much
more recent than any of those examples. I've got to say, I loved the A series launch. I mean, that was a huge thing. We've gone from SGX to Rogue to the architecture that need not be named, and then suddenly the company went through probably its most tumultuous time. 2017, obviously going private again. Lots of things going on, beyond any sort of R&D or creating the technology, and then to suddenly come back 2019 with the A series and significant performance leap and our biggest launch events, and things that really hadn't been on the cards for such a long time. I mean, we went for nearly 2 decades with no desktop play at all, and then suddenly look at us today with all the desktop customers we have, built on the back of the A series and subsequent series launches. So I'm really pleased with that.
Yeah, I think a lot of the proudest moments are where we've done things first, but not always to a commercial success, or it was just something you played with. But you then look back, we kind of did that way before anyone else did. We've done a lot of things in the compression space that Simon has worked on. But in the very early MBX days, again, we had our VGP, or our vector geometry processing unit, which was a very fast floating point unit. And it was way faster than what the CPUs, the CPUs had a bit of a floating point pipeline, but it wasn't to the same level. And we actually developed a compute library running on that. So way before OpenCL or any of these standards existed, we played around with this, but didn't really take it anywhere. It was kind of a play toy. And then you realize all those years later, OpenCL and where compute on graphics cores is today. But actually all those years back, 2004, 2005, we were already playing with those same concepts. And that keeps coming back. We go like, oh, we did this so many years before, but we couldn't quite see where it fit in just yet.
Well, I think that is highlighted by ray tracing.
And the ray tracing is again one of those examples, right? You spot that there is something there, but how, as an IP supplier, that's not always the easiest thing to really push some of those new concepts out there.
But really,
chicken and egg.
Really proud. Do you remember that first demo we did of ray tracing at a show? We had an NVIDIA card, we had a Plato card, and we had the NVIDIA card, their high-end NVIDIA card, running their demo of ray tracing, which was a robot sat on a bench, wasn't it? But it was really complicated ray tracing image, and it was running at, I think it was less than 1 hertz. I think it was maybe 5 seconds per frame, and our card, which was only 7 watt mobile GPU with ray tracing, was running more like 15 frames per second on the same scene, their scene. That was pretty cool. It got a lot of attention at the show.
It did. Yeah. So I mean, we've talked about ray tracing. We've talked about tile-based deferred rendering. What about other key features or innovations?
Take it back to some of the VR stuff. When Oculus obviously starting to drive that from desktop PCs, our guys went, I'm sure we can connect this headset up to this mobile phone. We just need quite a few dongles, but we managed to make that work. And that's originally where, things we originally developed for automotive came in, because you needed a priority extension. And even the desktop space didn't really have that. Like, how can we do this time warp, but make sure that it comes in at the correct time and takes over from whatever else you're doing. And we had exactly the same thing for critical renders in automotive way before that. So taking those extensions, and even today in OpenGLES, that's still the IMG priority extensions that are being used for that. So again, spotting these new things, bringing them out, and way too many dongles to get USB input from the sensors and then sending it out as two HDMI screens next to each other effectively, and driving that off a Samsung phone.
I remember the other day we were having a debate about where transformer lighting suddenly came into the product line. Did you ever work it out, Simon? What was our first?
Our first transformer lighting. Well, you could either say the Elan chip that we made to drive two CLXs for Sega's Naomi 2 cabinet. I mean, that was pretty powerful for its time, what it was doing. Certainly it outpaced any of the programmable transformer lighting systems that were out there. But it was only semi-programmable, I guess. So next one would have been MBX. Would that be?
Probably VGP, yeah.
Yeah, we did start work on a desktop system. Unfortunately, that sort of fell through. I don't think we had the partner pulled out of it, which is unfortunate, because that could have done tessellation, had recursive systems that you could do recursion inside the shader code and things like that, which was just kind of unheard of, really, as far as I can tell.
Yeah, the great white whale, Cairo 3. I mean, extraordinary moment, completely done, designed, test chips, the whole bit, and then suddenly we're not in desktop for a long time, and now we're back there again. But it's an interesting moment. I mean, it's great to be in desktop cards, but it feels like everything is moving towards the data center and the cloud. I mean, what do we think about the future for, yes, PowerVR, but GPU in general? Are we seeing big transformation, or is it just going to settle down and everybody's just going to be back to their PCs in 2 years' time?
It's all efficiency, right? The key thing that keeps coming back in our success is efficiency. In the early days, there wasn't the memory footprint or the bandwidth to drive it. And, the whole tile-based and deferred rendering helped with that. Console, cost-centric, again, it gave you massive benefits. And then, of course, mobile, exactly the same things. Efficiency, battery life became everything. But for a while, that scarcity of bandwidth or the power in PC systems was almost irrelevant, right? And some of the behavior we see today is still the same, right? Oh, more power connectors, more power, right? Just throw 100, 200, 500 watts, now I think 800 watts into GPU systems. And we're sitting there, well, our mobile phone budget is 1 watt. We have to make it work, and it has to support a lot of the same Vulkan and, going forward, DirectX APIs.
But that allows it to then go into any of these.
And that now means that in all those markets, you can get a massive benefit, because the data center, what constrains it's again, density in the data center. How much more processing can I get in the same rack under the same cooling? It's all efficiency again. And that's really what is attracting customers continuously to us, is that efficiency.
It's what's attracting our customers. But actually, you ask what will happen. Will people be back at their PC? And I think there's a different thing driving the industry now. I mean, this is driving how people interact with technology. They won't. We're setting up the scene so they can have diversity. So people don't necessarily want to replace their phone every year, because it's expensive. It's getting more expensive. So they'll be interested in moving to taking games from the streaming service. Initially, they want to just have access to all the games because they just want flexibility and diversity. But the reality is they want games that won't play on their low-end phone because they can't afford the high-end one. So they'll buy a service, and that service is then just opens up a whole range of capability for us, because we've got the high density, we've got the low power, we're adding visual fidelity. Ray tracing brings that. It doesn't matter where it is in in the system, whether it's at the edge, whether it's in a big data center somewhere, you can see high quality graphics on a mobile phone these days. So people will just get whatever service they can, you then move that into the metaverse, and what they're asking for is local rendering to make it really high, rich and fast, and they'll want high quality imagery coming from elsewhere, which is AR, VR, XR, whatever you want to call it, that's going to be in data centers. So we've got all of the technologies to be able to position that wherever we want it to be.
But simply, if you're a long way from a data center or not connected, you'd want something, say, on a laptop, which has all that high power rendering, but won't burn your lap when you've got it sitting there. So again, the low power would be, but high performance would be useful.
Yeah, exactly.
Certainly can't play the data center game if you're on the plane.
We've talked quite a lot about efficiency and low power, and slightly at a tangent here, but one of the big eye-opening moments for me when I first started here was we launched a card. I think it was the original version of the Neon 250, and we launched it with passive cooling, and I was responsible for putting it out for review and whatever else. So I was reading all the comments that would come in about this product, and all of them basically went, oh, it's not got a fan on it. Clearly must be significantly underpowered. And, benchmarks obviously were saying completely the opposite, but people would look at it and go, no fan? What's that? So we went and bought the cheapest fan we could possibly get on the market, and got these boards and stripped off the existing heatsink and put the fan on them and repackaged them in the box. Off they went. And never heard about that again. It's just like, oh, what a great board this is. There's still people today going, this is my favorite graphics board of all time. I'm like, okay, well, you didn't want to buy it when it only had a heatsink on it. I had to put a cheap fan on there before you take it from it. But I think there's been quite a few moments like that where it's sort of difficult to get across to people, how fundamentally different PowerVR is, and how much that knocks through into our ability, for example, to do the original mobile products, when the state of the art for gaming was Snake, and suddenly you said, oh, we're going to bring Tomb Raider onto your phone. I guess we should talk a little bit about t-shirts here.
Oh, right.
We've
You just want to show up, Graham, don't you?
Graham, of course,
I'm
has
in
the
the
giant
business side,
PowerVR.
you see.
Oh, I see.
Graham has the giant PowerVR tattoo, but he doesn't like
of
to get
course.
it down.
Yeah, you cut my arm off and it says PowerVR right through it.
So what are you wearing, Simon?
Oh, I'm wearing a Sega Dreamcast GOT modem, which I guess was probably a US t-shirt, based on, because I think they had a Got Milk promotion for the dairy industry out there.
Yeah.
So yes, obviously Dreamcast first console with internet connectivity.
Yeah,
Fascinating.
I remember that moment. We did a show in the States, Comdex, I think it was, and it was during quite a quiet bit. It must be like the last day of the show. Everything was very quiet. Hardly anybody was on our booth. And then Bill Gates showed up out of nowhere with his retinue to talk about, the Dreamcast. It was the first console that ran a version of Windows CE, I think.
Yeah.
And, with the modem and the whole bit. And he's just like leading people around. It's like, oh, Bill Gates. That's a cool thing. But yeah, that was the t-shirt of that particular moment. Kristof?
I have no idea. It's one of the GDC years, so there's too many t-shirts. This one is the least specific, I think. Because in most years we would link it to some of our demos. So there's t-shirts of the Soft Kitty demo. There's the kind of gnomes that we've done. So there's usually a link to some of the demo technology. This one I can't remember why we did.
But it highlights our triangle technology and the objects being cut apart. This is in every piece of documentation since day one till now.
Yeah, we've redrawn that image so many times. So many times. Well,
Really redrawn it, or just gone and copy and pasted?
No, we've
been
redrawn it.
It's been animated and all kinds of things.
So I've got the Jet Set Radio t-shirt, Dreamcast era game, which I was absolutely obsessed with at the time, and played again not that long ago and found it still really holds up. I mean, fantastic, you know. And a strong political statement in there as well. So yeah.
My favourite was Crazy Taxi.
Oh.
Laughed so much during that.
Crazy Taxi.
And I'm still pretty sure I wouldn't be able to drive that car around the track either for any of the racing games that we produced. But
We had some fun with trying to produce tools, because the original PowerVR was very much this, let's intersect a whole stack of infinite planes to create your objects. So a tetrahedron was literally 4 surfaces, a cube could be 6. So compared to representing by triangles, you could actually represent with very little data. But we kind of tried, so one of our colleagues was trying to take an off-the-shelf polygonal duck and trying to convert them into just infinite planes. And I don't know how he still has his sanity, to be honest. It was just...
it went on for months.
It did, yes.
There was variations of this, and every now and then he would find there was a triangle that didn't work. There were so many different complexities about this standard duck, and ever since then the duck's gone through the whole of our marketing ethos. It just comes back and back, doesn't it? But yeah, he gave up. It took him. He was literally on it for 1.5 years, I think, trying to get triangles converted into planes that worked in all scenarios.
Did solving the duck problem go on to help us significantly?
Oh yes, it made us convert to triangles in our whole concept. We suddenly realised there was a flaw in the underlying technology and it needed to be fixed.
It was all right if you started, if the artist started with those and built everything from that. But if you're just taking off the shelf stuff with your triangles, stick with triangles.